Welcome to Ask and Learn.
Okay, well, in this problem, we just need to explain what is the difference between the ideal diesel cycle and the ideal Otto cycle. And first of all, let's remember what is the definition of an ideal diesel and an ideal Otto cycle. So let's put here the PV diagram for the diesel. So here in the left is going to be the diesel, and in the right is going to be the Otto. This is PV. Well, the diesel is described by uh, an isentropic transformation followed by a constant pressure transformation. Then we have another isentropic transformation, and the final one is a constant volume transformation. So 1, 2, 3, and 4. We know that the heat enters in here and leaves in here, and this is an isentropic. So isentropic and isentropic here also. And what is the Otto cycle, the ideal Otto cycle? So the ideal Otto cycle, let's put here PV, and this is the ideal Otto cycle. This is going to be an isentropic transformation followed by a constant pressure transformation, then another isentropic, and then another constant pressure. Sorry, constant volume, not constant pressure. So again, the heat enters here and leaves in here, and these two are isentropic. So as we can see, the difference between an ideal Otto cycle and the ideal diesel cycle is that in the diesel cycle, the heat addition, the transformation 2, 3, in an ideal diesel cycle takes place at constant pressure. So while in the Otto, the 2, 3 transformation takes place at constant volume. Okay, so the main difference between the ideal diesel with the ideal Otto cycle is that the heat addition in the diesel cycle takes place with constant pressure, and the heat addition in the Otto takes place at constant volume. So that's the main difference between both of these cycles, and that's the final answer. Thanks for watching.